Okay, ladies and gentlemen, this is the test review part 1, where we are going to factor this quadratic equation and complete all these steps over here and then sketch the graph. I will be using a pen, but this is a big no-no for doing this when you're doing it. You want to use a pencil so you can make use of the eraser when mistakes happen, and they might happen right here when I do this, but we will try to make the best of it. The way I thought about doing this is I thought I would show both the hand algebra work, like, old school, and then bring in the calculator and show another way of getting at the answer that would be more aimed at star. So let me just dive right in with number 1. And guys, if you're watching this, please make use of this on your own homework assignment, because by watching this you're learning, and if you follow me through this whole video and you gain something from it, I don't mind if this video helps you get a good grade. I'm more interested that you understand. So with that in mind, let's start. Given f of x equals x squared minus 9x plus 8. Okay, show all work here. The very first thing we want to do is factor the quadratic. All right, so remember our trick. Here's the trick. Okay, the trick is we need two numbers that add together to equal the middle term, -9. And I also need those same two numbers to multiply together to equal the last term, okay, which is +8. All right, this needs to be on your paper. Write that down. So what we do is we take the 8, the last term, and we start to find factors. Let's give an example where this won't work. So I'm going to start with 2 and 4. Well, 2 times 4 is 8, but 2 plus 4 is +6. Well, I need the two factors to add to be -9. Well, they don't add to -9, so no, those don't work. Now I'll try 1 and 8. 1 times 8 is +8. Fantastic. But 1 plus 8 is +9. And remember, I need this to add to -9. So 1 plus 8, those will not work. What else might we try? It seems like we're out of options. But remember your negative factors. So now we'll try -2 and -4. Well, a negative times a negative is a positive, so -2 times -4 is +8. Fantastic. But -2 plus -4, or -2 minus 4, is -6, which is not -9, so it can't be -2 and -4. So that leaves us only with -1 and -8. All right, so -1 times -8 is +8. Fantastic. And -1 plus -8, or -1 minus 8, is -9. So yes, these are our factors, -1 and -8. -1 and -8. And what I'm looking for here is, do these meet our little test? -1 plus -8 equals the middle term, -9. Okay? And -1 times -8 equals the last term, which is 8. So that means I can write my factors. Okay? X and X. And I'm just going to write exactly what appears. X minus 1 and X minus 8. Okay? So that's the factored form if you wanted to write it. F of X equals X minus 1 and X minus 8. Now, before I go over here and fill this in, I need to check to make sure that I'm right. That little y means yes. All right. So we're going to either use the box method or the FOIL method to prove that these two factors are this quadratic equation. So how do we do that? Well, first we'll do the FOIL method. First, outer, inner, last. Let me write that here. FOIL. FOIL is first, outer, inner, last. The first term, okay, plus, so the multiplication of the first terms, x and x, the multiplication of the outer terms, x and -8, the multiplication of the inner terms, -1 and x, and the multiplication of the last terms, -1 and -8. You just add those all together. So here's how FOIL works, or here's how it looks. You don't have to draw these lines. I'm just drawing these lines to show you what I'm multiplying. First, the first two terms, x times x is x squared. Okay, don't tell me 2x. X times x is x squared. So that's first. Now outer, -8 times x. Just draw the little lines here. -8x. Inner, -1 times x. That's -1x. And last, -1 and -8 multiplied together. All right. -1 times -8 is +8. All right, now look at here. I've got common bases, x and x, so I can combine these like terms. So let's just say, what is -8x minus 1x? Well, that's -9x. Okay, so I've got x squared minus 9x plus 8. Now the question is, does this match the original quadratic equation? X squared minus 9x plus 8. X squared minus 9x plus 8. Yes? And what those two check marks to me indicate is that I have proven that these are indeed the factors of this quadratic expression or equation or function. All right? So now I can actually go in here and write this in, x minus 1, x minus 8. X minus 1 and x minus 8. Did I use box or FOIL to prove correct? Yes. Okay. I'll use box on the next problem, but for this one I used FOIL. They both work the same, basically the same way. Okay, now on to zeros. How do I find zeros? All right, so here's how you find zeros. You just move past this, make a little mark. This is my new section. This is my finding zeros. You've seen Finding Nemo. This is finding zeros. Finding zeros. Okay, so here's how we find zeros. We take our factors and we set those factors equal to 0. So I've got x minus 1 equals 0, and I've got x minus 8 equals 0. So what I've done is I've taken each of my factors and I've set them equal to 0. I've dropped the parentheses and I've just set each of my factors equal to 0. And now what I'm going to do is solve for x. So here's the process written out. Set each factor equal to 0 and solve for x. Set each factor equal to 0 and solve for x. So let's solve for x on this first factor right here. I'll add 1 to both sides. Okay, that cancels that out. And now I've got x equals 1. So there's one of my zeros, 1. Now over here I've got x minus 8 equals 0. I'll add 8 to both sides. Cancels that out right there. And now I have x equals 8. So 8 is one of my zeros. Now those are the two zeros of this quadratic function. All right, so we'll go over here and I'll put in, we'll call 1 x1 and we'll call 8 x2. We'll say this is 1 and 8. And for some people it might be helpful to remember that these are coordinates. This is 1, 0 and 8, 0. In other words, these are the two places where this quadratic function crosses the x-axis. Okay, that's what these two things mean. All right, how about the y-intercept? Well, there's something you should remember about quadratic functions, and that is when they are in standard form, the y-intercept is in this last position right here. So I already know the y-intercept is 8. Okay, I know that because ax squared plus bx plus c is the standard form of a quadratic, and in such a standard form as this is in, 8 represents in that position the y-intercept with its sign, so positive 8. But let's just say I wasn't sure about all that. I know that the y-intercept is the place where, I know that the y-intercept is the place where x is 0. I want to know what is y when x is 0. So this might be a chance for you to use a little bit of your brain, and we can evaluate this function at 0. In other words, f of 0 equals 0 squared minus 9 times 0. If you notice this, I'm just replacing each x that I find with a 0. So I've got x squared, I've replaced it with a 0, made it 0 squared, minus 9 times 0 plus 8. Okay, well look, 0 squared is 0, and negative 9 times 0 is 0. The only thing that's left is 8. So when this is all said and done, that goes away and that goes away, leaving just 8. So f of 0 is 8. And remember, the 0 right here is in the place of the x. So x is 0, y is 8. So the y-intercept is 8. Right? So if you can't remember how to read it right off the quadratic, or if the quadratic is not in standard form, then you can actually just evaluate whatever your function is at 0, and it will give you the y-intercept. Okay? All right, moving on. The coordinates of the vertex. Oh boy, this is traditionally the hardest part, but it does not need to be the hardest part. Okay, so I'm going to carve out some more workspace here. Let me just cordon off a nice working area for us here. And this is where we're going to work on the vertex. Okay, now the vertex of a quadratic function is either going to be its lowest point or its highest point. Now, how do you know which one you're looking for? Well, let me show you. What you do is you take a gander at the very first term in your quadratic, and you ask yourself, is that negative? It's not negative. It's got just x squared, so it's positive x squared. That means that the graph is, so if you have here, if it's positive, the graph is going to be hooping up like that, okay? So the vertex of the graph is down here on the bottom. That would be the minimum point. if this had been a negative x squared right here, then that graph would be pointing down like this. Okay, and now the vertex would be up here, and that would be called a maximum point. Right, so here we're dealing with this positively sloped quadratic function, so we're dealing with a minimum point. So what we're looking for, we're already trying to think about what our graph is going to look like, and we know that the vertex is going to be the lowest point on the graph. So this is the lowest point on the graph. Okay, and what we're actually looking for are coordinates. We're looking for a pair of coordinates, an x coordinate and a y coordinate. So I'm going to fill this in. That's what I want to know. X and y coordinates of the lowest point on the graph. So in other words, I want these coordinates right here, the bottom of the graph. Okay, so let's start to figure that out. The first thing is find the x coordinate. Okay, the first thing you should do is find the x coordinate. Now, here's an interesting observation. The x coordinate, I'm going to write this out, is equal to the axis of symmetry. All right, so whatever the axis of symmetry is, and we're going to talk about what that is, I'll put it right here, it is the point where I can divide the quadratic function cleanly in half visually. That's too small, so I want to make it a little bit bigger. Whatever my quadratic function is, okay, like let's just say that this is the quadratic function, there's always going to be a symmetry to it, right? It's going to be a symmetry, a vertical symmetry. And what I want is I want to know the coordinates, or the x coordinate of this symmetry line right here, okay? See, on the left, I have the symmetry, right, with the right side of the pink line. So this axis of symmetry cleanly splits the graph into two equal parts. That's the axis of symmetry. So I want to find that, and there's a real easy way to find it. Okay, so here, you need to know this. The axis of symmetry, the axis of symmetry, I'm right here. The axis of symmetry is equal to the average distance between the two zeros of the quadratic function. Okay, that's a lot to write, right? But it's kind of like you should write this, you know. Yes, you should write this. Okay, the x-coordinate is the axis of symmetry. The axis of symmetry is equal to the average distance between the two zeros of the quadratic function. Maybe that looks complicated, right? But it really isn't complicated. We'll show you what that means. What are our two zeros? 1 and 8. So how would I find the average distance between 1 and 8? Well, I would just add 1 plus 8 and divide by 2. A simple average. 1 plus 8 divided by 2 equals 9 divided by 2. And 9 divided by 2 equals 4.5. That's the axis of symmetry. So again, back here, if this is my little fake graph, here, this is how this is supposed to work. There's your x-axis, and here's your y-axis. Okay, here's one of the zeros we found. This is 1. Okay, here's the other 0, and that was 8. So this axis of symmetry right here, that axis of symmetry is 4.5, which is halfway between 1 and 8. Okay? So, all right, good enough. So now we found the x coordinate, 4.5. How do I find the y coordinate? All right, well, here's how you find the y coordinate. You, just like you did over here to find the y-intercept, you evaluate the quadratic function at the axis of symmetry. Look at this. Makes sense. Here's the quadratic function. It's this line right here. All right? So all the infinite number of points along this continuous curve, that's the quadratic function. So what I want to know is, what is the y value right there? Well, I know the x value is 4.5. So what's the y value at the bottom of that hoop? All right, well, we can find that by plugging in 4.5 everywhere we see an x in this quadratic function. All right, so what we would do is we would evaluate f of 4.5, and that would be equal to 4.5 squared minus, remember I'm following this quadratic, minus 9 times 4.5 plus 8. Okay? So I'm keeping this really, really low tech for this first run through. I'm not even going to use a calculator. Okay? So first I've got to find 4.5 squared, which is 4.5 times 4.5. So I'll just do that here. 4.5 times 4.5, because that'll give me 4.5 squared, right? Well, let's see. It's been a long time since I've done multiplication, and I bet it's been a long time for you as well. Let's see. 5 times 5 is 25, so I'll write 5, carry the 2. 4 times 5 is 20, plus 2 is 22. Okay, now we're going to do this one. 5 times 4 is 20, put a 0, carry the 2. Okay, another little 2. 4 times 4 is 16, plus 2 is 18. So I'll write 18 right there. Now we will add up this. 5, 2, 0 for the 10, carry a 1, and then 2. 2025, and I need to go over 2 decimal places. So 20.25. All right. So that's 4.5 squared. 20.25. So I'll just write equals 20.25 minus, now I've got to do 9 times 4.5. So I got 4.5 times 9. Okay. So let's see what that is. That's 5 times 9 is 45. Carry the 4. 4 times 9 is 36. Plus 4 is 40, so 405. I've got one decimal, 40.5. So it's 20.25 minus 40.5 plus 8. Okay, so now we're really getting in the weeds with the calculations here. So let's see what I'm going to do here. I'm going to subtract 40.5. Let's see. I can add 8. All right, let's just do it. Let's do it in order. Okay. Let's add 8 to 40.5. That gives me 48.5. And then we'll just subtract 48.5 from 20.25. So I've got 48.50, oops, minus 20.25. Let's see what that gives us. Okay, 4, 10, 5, 2, 8, 2, 28.25. Negative 28. Negative 28.25. Make sure that that's right. I don't think I might have made a mistake somewhere. 5 times 5 is 25. Okay, carry the 2. 4 times 5 is 20. 22. 20. Okay, 2. 4 times 4 is 16. Plus 2 is 18. 5, 2. Okay, 10, 2, 20.25. Then I got 4.5 times 9. That is 45. 4 times 9 is 36. Plus 4 is 40.5. Okay. So just want to make sure that I didn't make a mistake here. I have 40.50 minus 20.25. Let me try it this way just to double check. And for I have 2 here, and then 3, 10. Oops. This don't need to do that. So it's 0 and 2. 20.25 plus 8. That gives me 28.25. And of course, that's negative 28.25. Is that correct? I have 20. Wait a minute. I think I see my problem. Okay. So I have here negative 20.25 plus 8. Aha. I see the problem. So I'm really going to be subtracting 8. All right, so I'm going to subtract 8 here. Okay, so now 20 minus 8 is 12.25. All right, good. All right, so this is still negative. Negative 12.25. What a lot of nonsense. My goodness. I tell you, we have become too reliant on the stinking calculators, because even your own math teacher made a stupid subtraction mistake. So it's negative 12.25. Okay, very good. So that is the y coordinate. All right, so negative 12.25 goes right there. So here are the coordinates of our vertex. 4.5, comma, negative 12.25. Okay, so it turned out, just to touch base on what went wrong in this subtraction, you must subtract first, okay, then add. Oh, interesting. Left to right. Okay. So now we have our coordinates, and we'll sketch the graph. So When we start to sketch graphs, we need to remember a couple of things. This is the lowest point on the graph, so I need to go all the way down to negative 13, 14, or 15, and then the domain of the graph, so the range of the graph needs to be at least negative 15 to positive 10, right? So if you're thinking about your vertical y-axis right here, let's see if I can get this centered. This y-axis needs to extend down till the very bottom number. My recommendation is negative 15. And the very top number is going to be 10. Okay, we'll fill in the rest, right? So maybe our x-axis starts right here. And what we can do is we can give this thing a wider breadth. So we have to go here 1, 8. So just like come up with some kind of scale. This will be 1, 2, 3, 4, 5, 6, 7, 8. I want to be super precise. 1, 2, 3, 4, 5, 6, 7, 8. And this is the x-axis, and this is the y-axis. All right, and I can just keep going, 9, 10, whatever. This is the origin point. Now, I got to figure out something to do here. So, let's see, I need to get 10, 1, 9, 8, 7, 6, 5, 4, 3, 2, 1. Nope. I have to do like thirds. So this would be 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, cool. So that's 9, that's 8. So here's 8. I'm just labeling my graph. There's my y-intercept right there. Okay. Now I'm going to do the same thing down here. This will be negative 1, negative 2, negative 3, negative 4, negative 6, negative 7, negative 1, 2, 3, 4, 5, 6, 7, negative 8, negative 9, negative 10, negative 11, negative 12, negative 13, negative 14, negative 15. All right, so we'll put negative 15 right there. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12.25. My axis of symmetry was at 4.5, so right about there. Now I'll plot in the axis of symmetry. Okay, right at 4.5. That's halfway between 4 and 5. Here's the axis of symmetry. Okay, now I plot in my zeros at 1 and at 8. And then I plot in the axis of symmetry at, or the vertex rather, at 4.5 comma negative 12.25. Okay, so that's going to be right here. That'll be the vertex of the graph. Okay, so if we're labeling the graph, like, so we understand what this is, here is the y-int right there, and here is x1, and here is x2, and here is the vertex. Just so we understand what's being graphed. Now it's time to play connect the dots. All right. So the kind of a question nobody asked today and needs to be asked is, if this is the y-intercept here, where's this other point? Because I'm going to try to draw in a curve. So how do I know what to do over here? Well, okay. So you can kind of guess, you can kind of estimate this. Look, just see the distance. Yeah, it really helps to use a ruler. I'll tell you, it really helps. So let's see, 1, 2, between 2 and 3 past the 3. All right, so I'm going to take my measuring stick here and go between 2 and 3 past the 3. Right there. So right there is another point. And the reason I'm able to plot that point in is because of the symmetry of the graph. See, these are going to sit on the same horizontal line, right? And there's a symmetry there. They're equidistant from the axis of symmetry. That's the only point you need to plot in, because now you can kind of color it in. Even though I am going to do this using a pencil first. Now, my recommendation is that you go real gentle with this. You sketch it in gently. You're trying to make a nice shape that really seems to flow, okay? So you want this to flow. Make it more of an artistic exercise than you're used to with math, because you're trying to make a very gentle curve, right? And then it's going to pivot at the bottom here with this little hoop, and then it's going to shoot back up. It's hard to make symmetrical shapes, but if you kind of just brush with your pencil, you can be more articulate about your drawing. You see how I'm just kind of gently shading it in, gently. You're really sketching. It doesn't have to be an exercise, and you're not trying to be Michelangelo or anything. You're just sketching in the graph, but you want it to look nice. Okay, so there's kind of the sketched in graph that looks pretty good. And now I'll give it a harder completion line with the pen. You know, take all the time that you need to with this. Don't rush it. Make it look nice. Like I say up here in the directions, put some pride in your work. All right? So if you really want to just cap this thing off, you can label this. Label this line f of x. That is super cool. F of x equals x squared minus 9x plus 8. Awesome. And that is how you do it. Okay? So that is number 1. Now, number 2, I will solve much faster. Again, this time I'll use the calculator. And I said I would show the box method here. Well, we'll kind of do a hybrid approach. On this problem, there's something we got to take care of. First, we've got to get this thing in standard form. This is not in standard form right now. It says n squared plus 7n plus 15 equals 5. It's supposed to not have anything over here. So we got to fix that. The first thing we have to do is subtract 5 from both sides. Okay, that gets rid of it on the right. And now we're going to rewrite f of n equals n squared plus 7n plus 10. Okay, so that is the actual standard quadratic. Okay, identify a couple of key features. There's your Y-intercept right there, 10. All right, I'll put that in, 10. All right, now what are we looking for in terms of factors? Well, I need two numbers that add together to equal 7, and those same numbers multiply together to equal 10. Okay, so let's factor 10 and see if we can find two numbers. I got 2 and 5. 2 times 5 is 10. Good. And 2 plus 5 is 7. Oh, we're already done. So that happens quite a bit. 2 and 5. And 2 and 5. So we'll write f of n, we'll write this in factored form now, equals open parentheses, close parentheses, open parentheses, close parentheses, just like that. X plus 2 and x plus 5. Okay, let's prove that it's correct. We'll use the box method. And here is the box method. First, I need to know, like, what size of a box do I need? Well, how many terms have I got in this factor? Got one term, two terms. How many terms in this factor? One term, two terms. So I need a 2x2 box. That's how I know how big to make the box. So here is the box. Let me make it 2 by 2. Okay, there's my box. All right, so here's what you do. You write this factor up here, and then you write this factor down here. Let me show you how to do that. X goes there above this box, and then plus 2 goes above that box. And then here you can write x, and here you write plus 5. This accomplishes the same goal as FOIL, but some people like the more visual approach. Now, multiply x times x, and you've got x squared. Multiply x times 5, and you've got 5x. Multiply x times 2, and you've got 2x. Multiply 5 times 2, and you've got 10. So now we just write out everything inside the box. X squared plus 2x plus 5x plus 10. Okay, we have common bases here with these two x's, so we'll add their coefficients. So I have x squared plus 2 plus 5 is 7x plus 10. Question, does this match this? I see I've switched the, I dropped the in. Sorry, my bad. Doesn't matter. So does this match this? Yes, it does. I should have written, and I'll fix it now, n squared plus 7n plus 10. Okay. Does this match this right here? Yes, it does. This is what we're going to be working with from now on. Okay, so this matches that. Therefore, I confirmed it. All right. So did I show box or FOIL to prove I'm correct? Yes. So now I can write my factors, x plus 2 and x plus 5. X plus 2 and x plus 5. Okay. Well, what are my zeros? Well, here are my zeros. Let me make some space. Here are my zeros. Guys, you see how I'm breaking up this section here? You should be doing that on your paper. You should be using the ruler to make it really clear. Like, what are you doing? You know? Like, everything here is neatly segmented. Everything should be segmented on your paper. That way you can show me what is going on where. You know, here's where I'm finding the factors. Finding factors. Right there. What am I doing here? I'm proving I'm correct. Right there, okay? Now I'm finding the zeros. And here's how I find the zeros. I write down the factors, x plus 2 and x plus 5, and I set them equal to 0, and I solve for x. So x equals -2, and minus 5, x equals -5. Okay, this is super important. Pause the video if you don't understand this. So here are my two zeros, -2 and -5. I want to make sure that negative is showing up. Okay, this is x1 and this is x2. All right, so, or n1, I keep writing x, whatever. Okay, so n1 is -2 and n2 is -5. Okay, so now we're working on the coordinates of the vertex. Here is the vertex. Well, first I need, okay, here's my coordinates. I need the axis of symmetry. Axis of symmetry. Remember, the axis of symmetry is going to be the x-coordinate, okay, or x. All right, so here's what I'm going to do. I will add up my zeros and divide by 2. So what is -2 plus -5? That is -7.5 divided by 2. Okay, well, -7.5 divided by, what am I doing? It's -2 minus 5 is -7. Sorry. -7 over 2. I'm getting ahead of myself. So -7 divided by 2 is -3.5. Sorry about the mistake. So now I've got the x value, -3.5. And what I want to do is plug that in. F of -3.5 equals what? Well, I'm going to replace all the n's with -3.5. So here I've got -3.5 squared plus 7 times -3.5 plus 10. Okay? Again, you know, without a calculator, see if I can't make a complete fool out of myself this time. I've got -3.5 times -3.5. All right, let's multiply this thing. Okay, 5 times 5 is 25. And 3 times 5 is 15, 17. 5 times 3 is 15. 3 times 3 is 9, carry 1 is, or with add 1 is 10. Okay, let me just double check. 5 times 5, 25. Carry the 2. 3 times 5, 15, 17. Then I have 15, carry the 1, 9, 10. All right. So I'll add this up now. And I have 5, 12, carry the 1, 2. Yep, and 1. Okay. It's a negative times a negative, so it's a positive, and I've got 2 decimal places, so 12.25. So now I've got positive 12.25. Now I've got to do -3.5 times 7. All right, -3.5 times 7. Well, let's see. 5 times 7 is 35. So I'll carry the 3. 3 times 7 is 21. Plus 3 is 24. And I've got a decimal there. Okay, 1 decimal place. And it's negative. So it's -24.5 plus 10. All right, let's do this now correctly. So what we'll do is we'll subtract 12.25 from 24.5. Okay, borrow 1, 10, 5, 2, 2, 1. Okay, 12.25, negative 12.25, plus 10. Alrighty. And I've got negative 2.25. Okay, so this whole thing equals negative 2.25. So when x is negative 3.5, y is negative 2.25. So up here I'll put negative 3.5 comma negative 2.25. Okay? So the coordinates of the vertex are negative 3.5 comma negative 2.25. Let me make sure I've got the signs correct. So we've got negative 12 plus 10. Yep, I think the signs are correct. Okay, so now let's think about what we're going to need to do here. I've got a y-intercept at 10, okay, and a tight range on the negative side. So this graph is going to be more kind of right aligned, right? So here is my y-axis. Okay, but this time I'm going to be working over in this region. So can make it like that, right? This is the x-axis. This is still 0. And what the y-intercept is 10. Okay, maybe I should have made this y go up farther. Okay, can do that. It's allowed. So let's see. Yeah. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is your, I'll draw it in blue. Here is your y-intercept right there. Okay, this is the y-intercept. And that's 10 at 10. And what else can I plot in? I've got my zeros at negative 2 and negative 5, so I got to draw these in. We can spread this graph out a little bit. So 1, 2, 3, 4, 5. Yeah. So this is negative 1, negative 2, negative 3, negative 4, negative 5. At this time I'm putting twice as much space between them just to spread it out more. You don't have to do that. In fact, maybe I shouldn't do that. No, I'm going to do it anyway. Okay, so this is a 0 right here. Negative 2. Negative 2 is a 0. This is going to be in 1. Okay. And then negative 5. So that's negative 2, negative 3, negative 4, negative 5 right here. This is in 2. Negative 5 and negative 2. Those are my two zeros. And what other point do I know? I know the vertex at negative 3.5, which would be the midpoint here. Okay. This is the axis of symmetry at negative 3.5. And I know the negative 2.25. All right. Negative 1, negative 1, negative 2, right about there. So right about here is the bottom of the graph. This is the vertex. Okay, so now I can again measure. So from 6 to between 2 and 3, from 6 to between 2 and 3. Right there. There's my other point. And I can sketch. It in. I'll sketch it in with a pencil. It's going to be big. It's going to cover up the page. That's fine. Okay, it's pointing up. That's fine. Okay. And right. You guys see how I'm just kind of almost shading it in, right? So I'm just trying to feel out the nature of the curve to the line. It's hard to draw, really, you know? Okay, so now I'll put in a darker line to finish it off. All right. Cool. Now we can be the OGs here and put, this is f of n. Label the curve itself, f of n equals n squared plus 7n plus 10. It's just so cool that we can graph that ourselves. Now, so we've done the work. This is what I wanted you to do, all right? This is what I wanted you to do. It's a lot of work. It's a lot of work. If you join me in a later video, okay, this one's gone on for 56 minutes, I will work these problems using the calculator, okay? Well, I'm going to say maybe I should just go ahead and do it in this video to get it out there. So what we'll do is I'll upload this video and then make a part 2 where I show the factoring with the calculator. Okay. All right, we'll end this video here. Thanks for watching.